In this video, when I find the area enclosed by this function over here, we have r squared is equal to 4 cosine 2 theta. I suggest you pause the video, try and solve the problem, then come back and see how I solve it. Okay, so what should be the first step? You're right, sketching the region. We should always start by sketching the region. So we need to know how does this region look like in the xy plane. I think if you try and sketch this function right away in the xy plane, it will be too complicated. So I suggest breaking this down into smaller steps to simplify the process. What I mean is, we want to know how does r change as we change the value of theta. So instead of sketching this right away in the xy plane, I'm gonna see how this function behaves in the r theta plane. So this is the r axis, this is the theta axis. And instead of sketching this function right away, I'm going to be sketching r is equal to 4 cosine theta. If I try and sketch this function, well, it's going to look like this, where this is 4, this is negative 4, this is pi, and this is 2 pi. Okay, now let's sketch the function r is equal to 4 cosine 2 theta. Again, this is the r-axis, this is the theta axis. So I'm trying to sketch for r is equal to 4 cosine 2 theta. Now this is very similar to this, except this time we have 2 times theta, which means the frequency is doubled, and we have 2 cycles from 0 to 2 pi. So it's going to look something like this. This here is 2 pi, which means that this midpoint here is pi. Of course, if you go back there, this is pi over 2, this is 3 pi over 2, and if you want to figure out the values here, you just divide these by 2. So this is pi over 4, this is pi over 2, this is 3 pi over 4, this is 5 pi over 4, 3 pi over 2, 7 pi over 4. We are almost there. Now we know how r varies with 4 cosine 2 theta. But remember, the function we're trying to sketch is this one over here, which we can simplify and write that r is equal to the square root of 4 cosine 2 theta. So going from this function to that one, we can just take the square root of every r value. So let me do this over here. Alright, so if you remember, this was 4, this was negative 4. So if you take the square root of 4, you get 2. So we start at 2, and we keep on going in this direction until we reach this point. Now, from theta equals 2 pi over 4 to theta equals 3 pi over 4, you see here that we have a negative value of r. If you take the square root, you're gonna have an imaginary number, and since in this course we do not deal with imaginary numbers, we're just gonna leave this region undefined. Because if you take the square root of a negative number, in this course you're gonna get an undefined answer. So there's nothing down there, and you keep going up, and there's nothing between 5 pi over 4 and 7 pi over 4, and then you go up. So this here is pi over 4, this is 3 pi over 4, this is pi, this is 5 pi over 4, this is 7 pi over 4, and this is 2 pi. Okay, so now let me have a table to record all these values. So we have theta and we have r. So when theta is equal to 0, we have r is equal to 2. When theta is equal to pi over 4, r is equal to 0. And then when we have 3 pi over 4, we have 0. Extend this. When we have pi, we have 2. When theta is equal to 5 pi over 4, we have 0. When theta is equal to 7 pi over 4, we have 0. And when theta is equal to 2 pi, we have 2. Now we know how does r change as we vary theta. So it will be a little bit easier to sketch the function in the xy plane. So this is x, this is y. Okay, so when theta equals to 0, r is equal to 2. And theta equals to 0 represent the positive x-axis. So along the x-axis, we're going to have this point here, 2. And if you look here, you see as theta goes from 0 to pi over 4, the value of r keeps on decreasing until we reach r equals to 0 at the angle pi over 4. So the angle pi over 4 is defined by this line here. So the line y is equal to x, where theta is equal to pi over 4. And we said that the value of r keeps on decreasing until we reach this angle. Now remember, the value of r is the distance from the origin to the function. So this is r, and you see it keeps on decreasing as we increase the angle, because the length of this arrow keeps on decreasing until we reach 0. Okay, we said that between pi over 4 and 3 pi over 4, the region is undefined. So let me sketch another line to represent these angles. This is theta is equal to 3 pi over 4. And this is theta is equal to pi. So when theta is equal to pi, r is equal to 2. And theta equals to pi represent the negative x-axis. So again, on the x-axis, this is negative 2, but the value of r is always positive. And as we go from theta is equal to 3 pi over 4 to theta equals to pi, the value of r increases from 0 all the way to 2. So we're going to have a region that looks like this. And again, you see the value of r at theta equals to pi is 2, and it keeps on decreasing if we go from pi to 3 pi over 4. Okay, and if we move from pi to 5 pi over 4, you see r decreases from 2 all the way to 0. So you're going to have this looking like this. And finally, from 7 pi over 4 to 2 pi, again theta equals to 0 and 2 pi represents the positive x-axis, it goes from 0 all the way to 2. Of course, it's a symmetric region, but my sketch isn't that accurate. So this is how our function looks like in the xy plane. So let me resketch this. Okay. So one way we can find the area of this region is by breaking it into 4 equal pieces. Because you see here, we can have this piece. It has the same area as this piece, and as this piece, and so on as this piece. Okay, so I can find the area of one of them and multiply it by 4 to get the area of the entire region. If you remember, this was r is equal to the square root of 4 cosine 2 theta. So now that we have our region of integration, we can set up the double integral to find the area enclosed. So the area for this part is going to be 1 times dA, which in polar coordinates is r dr d theta. Now we need to figure out the limits of r and theta. So for r, we start at the origin and we go radially outwards. and you see that at 0 the region is defined, and that we always exit the region through the curve. So the lower limit would be 0, and the upper limit would be the curve, which has the function r is equal to the square root of 4 cosine 2 theta. Also remember we had this line here, x is equal to y, and the limits for theta is going to range from 0 to pi over 4, because when we go counterclockwise from the positive x-axis, at 0 the region is defined, and the region ends at this line, which has a slope of 1 and the value of theta of pi over 4. So theta is going to range from 0 to pi over 4. So this here represents the area of just this part. If we want to find the total area enclosed, we're going to have to multiply this by 4. Alright, so now let's integrate. If we integrate r, we get r squared divided by 2. Again, I'm integrating the inner integral, and this is gonna vary from 0 all the way to square root of 4 cosine 2 theta. So we're gonna get 4 cosine 2 theta divided by 2 minus 0, which is equal to 2 cosine 2 theta. Now we're integrating. We have 4 from 0 pi over 4 2 cosine 2 theta d theta. If we integrate this, we get we get sine 2 theta multiplied by 4, and theta is going to vary from 0 to pi over 4. So if you evaluate this, you get 4. Sine 2 times pi over 4 is sine pi over 2, which is equal to 1, minus sine 2 times 0, which is 0. So we get 4 as the final answer. If you have any questions, please leave them down in the comment section below, and I'll be more than happy to answer them. Good luck.